lab, we are going to create a package symbol for a 16-pin dual inline package. First, start the PCB editor, then choose a new file, and in the drawing type select package symbol wizard and give the drawing name as zip16. Then select OK. Then a new dialog window appears. Then you can select DIP. Then click next. After that, template drawing file, select as a default Cadence supply template. You can load the template and then click next button. There you can change the units used to enter dimensions in the wizard as shown 2 and 2. Then you can change the reference designator profile. Then click next. Select the number of pins as 16 and the lead pitch as 100. Spacing between two terminal rows as 300, package width as 200 and the package length as 785. Select next button to continue to next form. There you can browse and scroll down to select a pad stack of 60C38D. Then click OK. Then browse button and click 60S38D. You can find pad 60 XSQ36D as shown in the window. A new package symbol appears. There you can click next, and from the select location symbols you can click center of symbol body. Then create a compile file, compile symbol. Then you can click next. There 2 pins appears. Then you can finish. Here is a DIP16 drawing and the symbol which are created. The footprint is open in the symbol editor. At this point you can make any changes that you require. If you don't make changes, be sure to save the drawing and create the symbol. In the next lab, we are going to create a DIP14 package symbol. Select a new file and name the drawing file as DIP14. And in the drawing type, you can select the package symbol. Scroll down to package symbol. Then create OK. Then click OK. There appears a new dialog box. Before that, we need to set the design parameters. To set the design parameters, click select setup design parameters, and in the type package, user units as mils and size A, accuracy as 2, left x as -500 and the lower y as -1500. Then click OK. The drawing parameter form closes. The drawing origin is now near the center of the work area. Next step is to add pins. Select layout pins from the top menu. The option window displays the fields for adding pins. In the options window, click the browse button. Then next to field of pad stack, a pad stack window appears. From there, scroll down to select a pad stack 60S38D as shown and then click OK. Then in the editor command window, a message area states using 60S38D pad. This means that the PCB editor program was able to locate the pad stack you specified. The pad stack is now attached to the cursor. To place pin, hover your mouse over the command tab to display the window if it is not already placed. Click the PCB editor command line to activate it. Then find the options window, click the browse button, then select the path stack as 60C38D. This is the path stack that you will represent the remaining pins of the device. Press OK. An editor message area appears. Then go to options. Give the spacing size as x1, 50 in the right, and y as 600, and just in the order buttons keep it as down. The PCB editor tool is waiting for a location for the array of pins. At the PCB editor command line, enter x, 0 and -100. Since pin 1 is located at the drawing origin, the starting point of array is 0 and -100. To add another column of pins 8 to 14 in the options window, double-click the quantity field of the y direction and enter 7. The options form is now ready to place an array of 7 pins, 1 column and 7 rows. The spacing between the rows is 100 mils. The first pin of the array will be 8 pin, followed by 9 pin and so on. But the direction needs to be upward direction. As you can see, the direction is upwards from 9 to 14. Click to change the direction. We can change the offset values. In the command line, enter x as 300 minus 600. Since the pin 1 is located at the drawing origin, the starting point for the array is 300, minus 600. The array of 7 pins is placed starting with pin 8 and progressing in the upward fashion. To make the pin numbers appear on the right side, place the cursor in the work area. Now we are adding an assembly outline. Select Setup Design Parameters from the top menu. Select the Display folder from the top menu. Select the Setup Grids browser button. The grids display form appears. Locate the non-etching area and double-click in the spacing field and enter the following. Once you click OK, the exit form disappears. Then select OK. Now we are going to add line from the top menu. Click Add Line from the top menu if you are not already in the command window. A typical silk screen outline is a rectangle that surrounds all the pins of the device and contains some kind of notch showing part orientation. Click Done. From the Add line, go to Options window, click the scroll button to show the available subclasses and change Assembly Top to Silk Screen Top. Click to specify the corners of the outline. As you move the cursor, you see the attached line. To exit the Add command, click right click and Done from the pop-up menu. Now we are going to set colors. Just click the color icon and the color visibility form appears. There you can select package geometry. Next you will change the assembly top subclasses to blue. Click a blue color in the palette area of the menu and assign it to the assembly top subclass. Click another color white and assign it to silk screen top. Click OK in the color dialog form. Now we are going to add the labels. The label is simply a location placeholder. Select Layout, Labels, REF this from the top menu. You can notice there appears a pick location. You need to enter U star. Which is name of the pin. This is the device type. U star is the name of the pin. Click Done. From Layout, select Label, Reference. The pop-up window disappears. In the options, from the active class, change the subclass to silk screen top. Once we complete this, we are going to create a package boundary. To create a package boundary, select Setup Areas, Package Boundary from the top menu. There appears a pop-up window. In the Options window, select Package Geometry and place Bound Top if necessary. We need to draw a polygon representing the area required for the placement. This is an outline that is used for all the pins. You need to drag the cursor and make an outline that surrounds the pin. finished, click done. It automatically fills solid. Next we are going to define the package height. From this setup areas package height, click package height. Then go to options window. We are going to select package geometry and place bound top. Then in the command window, we need to give the maximum height. You can take the maximum height as 180 mils, which are the units. Click done. We need to save the symbol to disk. File, save as. The system saves a dip14.tra file. It also creates a symbol dip14psn, which can be used for further lab. Now we are going to create an SOIC 16 with the symbol editor. Select a new file from the top of menu, enter a drawing name as SOIC 16 and in the package symbol, click OK. Now we are going to set up the grid. Set up design parameters from the top menu, then display. We are going to give the X field as 25, Y field as 25, then click OK. Click OK. We are going to add the pins in the next section. This device contains 2 columns of 8 pins. To do so, you need to go to Layout from the top menu, then select Pins. Go to Options window, select Browse option. You get a Select Patch Stack window. There you can scroll down to search for a patch stack of 76 by 24 SMD. Click OK. This is a patch stack that will represent the pins of the device. In the options window, you can give the values for quantity and spacing. In the PCB editor command line, enter the values as X00. This locates the drawing origin in the downward fashion. You can zoom into the area surrounding the pins you just placed. To add another column of 9 pins, go to Options window, change the direction of the rows, which is currently set to down, by selecting the Y order field to up and the offset X value as 50. In the command line, enter the value as X 225 and minus 350. Click done. Go to add pin, click to right, select done from the pop-up menu. Now we are going to add an assembly outline. To do so, go to options window and select the package geometry and assembly top. You need to add assembly graphics to this layer. to draw the corners of the outline. Click done. Then go to options, select it as assembly top. Then you need to draw the corners of the rectangle. Once you complete this, right click and done. We are going to add labels. Set up layout, labels, then REFDES from the top menu. We need to change the orientation and text size. Go to options and rotate the field as 90 degrees and change the text block field to show a size of 2. Click inside of the device to define a location for text. In the command window, enter the name as U star, right click and done. You can change the orientation accordingly. Silk screen top, orientation. We are rotating it to 90 degrees and giving the command line as device type U star. Right click. Now we are creating the package symbol and drawing files. Before that, save this file. The system saves as SOIC 16.dra file. This file you can use it to edit in the graphics.